Today we will see how to round off numbers, round up or round down numbers to a certain degree of accuracy. So, when you want to round a number to the nearest 10, we can round numbers to the nearest 10 or to the nearest 100 or to nearest 1000. So you can go on like that, and you can also round numbers to 1 decimal point. And what does that mean? Round a number to 1 decimal point is rounding it to the nearest 10th. 2 decimal point will be rounding the number to the nearest 100th. So we'll see how to carry out these. Now supposing you want to round this number 76,382. We will keep this. We will round it to the nearest 10, we'll round it to the nearest 100, we'll round it to the nearest 1000. So when I want to round it to the nearest 10, that means I'll have to have 1 0. It should only be in tens. That unit digit should be 0. So if I want the units digit to be 0, so I can just take the last 2 digits and see between which two tens this 82 lies. 82 lies between 8 tens 80 and 9 tens 90. Now 82 is closer to 80 or is it closer to 90? You can say that 85 is the one that is exactly in the middle. So 82 is closer to 80 than to 90. So it gets rounded to 80. So this number 76,382 is approximately, it is rounded to 76,380. Its approximate value is 76,380. So rounded to the nearest 10. So that's why we say nearest 10. Rounded to the nearest 10. Now let us round the same number to the nearest 100. 76,382. Here I need to have 2 zeros at the end, 100. Because 100 has 2 zeros, the last 2 digits will be 0. Now I take 3 digits here and I will see what are the 2 hundreds just above and below this 382. So you have 300 and 400, and right in the middle you have 350. And where is this 382? 382 is after 350, so it is closer to 400. So now the last 3 digits will be 400. 76,382 will be rounded to 76,400. Now we'll also do to the nearest 1000. So 76,382. Here the last 3 digits should be 0, which means it will be 000 at the end. Now you take these 6,382 and select 2 thousands immediately before and after, 2 consecutive thousands. So you have 6,000 and 7,000, and you find that 6,382 lies between these two, but the one right at the center is 6,500, and you know that 6,382 is to the left of 6,500, so it gets closer to 6,000. That means when I am rounding it to the nearest 1000, your answer is going to be 76,000. Rounded to nearest 1000. Now every time we cannot be looking at 2 tens above and below the number, hundreds below and above and below the number. There should be some shortcut to do this rounding to the nearest tens or 100. So now take this same number 76,382. If I want to round it to the nearest 10, you just draw an imaginary line between the ones and tens. Now you want to make 2 as 0, right? If 2 is less than 5, ignore it, make it into 0. So the 2 is ignored and it is converted into 0, 76382. Here I notice that 2 is less than 5. So 2 is converted to 0. It is changed to 0. If it is 5 or greater than 5, if it is 5, 6, 7, 8 or 9, then I will add 1 to the previous digit. 1 will be added to the previous digit. Now you will see that in the next rounding up. So now I am going to, this is to the nearest 10. Now I am going to do to the nearest 100. And I am going to follow this shortcut. So 76382, nearest 100. So what I do is I just draw the line before the units and tens, that is between the hundreds place and the tens place. Now I see the number that is immediately after this imaginary line. It is 8. Now 8 is greater than 5. So 1 is added to the previous digit. So now I get, and then the 2 digits after that imaginary line are converted to 0. 82 is changed to 0, 0. Okay, so now this is 7, 6, 3 plus 1 is 4, and this is 0, 0. So to the nearest 100, it is 76,400. Now we'll also see to the nearest 1000 using the same method. 76,382. I want to round it to the nearest 1000. An imaginary line goes here. And what is the number immediately after the line? 3. So immediately after the line is 3. Now that 3 is less than 5. So it is ignored. The last 3 digits are changed to zeros. So now this is rounded to 76,000. So this is rounding numbers to tens, hundreds, thousands, etc. You can follow the rule even for other numbers like 10,000 or 100,000. The same method can be followed. Now we will see how to round numbers to 1 decimal point and 2 decimal points. Similar procedure can be taken up here also. So say if I have 13.768, consider this decimal, and I want to round it to the nearest whole number. Now you can, the concept is the same. You see to which whole number this 13.768 lies between 13 and 14. It is closer to 14, so it will be rounded to 14. The concept is just the same, but we will follow the shortcut so that we can save time in doing this rounding of numbers. So when I want to round it to the nearest whole number, the imaginary line comes here. And immediately after that is your 7. 7 is greater than 5. So 1 is added to 3. And the decimals are ignored. So this is rounded to 14, to the nearest whole number. Because we don't want decimals, that's why we are rounding it up to the nearest whole number. So you see the number, the digit that comes immediately after the point. If it is less than 5, ignore it. If it is greater than, if it is 5 or greater, add 1 to the ones digit, which is 3 over here. Now let us round this 13.768 to 1 decimal point, to the nearest tenth. 1 decimal point meaning to the nearest tenth. DP stands for decimal point. So I write 13.768. The imaginary lines comes after the 10th digit. See the number immediately after the line. What is it? it is 6 over here, and you know that 6 is greater than 5, so 1 is added to that 7, the digit that is before the line. So your answer is 13.8. Correct to, you say that this is correct to 1 decimal point. Now we'll correct the same thing to 2 decimal points. So 13 point, now let me change the number. I'll write it as 796. Correct to 2 decimal point. Or you say the nearest hundredth. Nearest hundredth. So the line comes over here. Immediately after the line is 6. Here you know that 6 is greater than 5. So 1 is added to 9. Then what happens when I add 1 to 9? That is why I'm adding 79 plus 1. It becomes 80. So here you have 13.80. Even though the hundredth place is 0, it is corrected to 2 decimal place. When I add 1 here, 79 plus 1 gives me 80. So this is correct to 2 decimal places, even though it looks like corrected to 1 place, because of that 9 over there. Now, instead of saying that correct to the nearest 10, nearest 100, nearest 1000, or nearest to 1 decimal place, 2 decimal place, they can also say correct. You can also write your answers correct to 1 significant figure. Correct your answers, correct your solution or to 1 significant figure. 1 significant figure. That means you should see only one number in your solution. Say, now let us take, this can be explained with an example, 28.76. Now you can see there are 4 numbers. I can see 2, I can see 8, I can see 7, I can see 6. But when I want to correct it to 1 significant figure, I should see only one number which is not 0. The rest of them should be zeros. So here again, the most significant, or the one with the highest value, is 2. In this number, the digit that has the highest value is 2. You retain that and then see what you have after that, just like rounding numbers. If it is greater than 5, 5 or greater than 5, add 1 to the previous digit and make the rest of it zeros. So here 3 plus 1, that is 3, and then you have to change the rest of the numbers to 0. So your answer is 28.76 is equal to 30. That is correct to 1, giving your answer to 1 significant figure. We write it as 1SF, 1 significant figure. 28.76 is equal to 30, correct to 1 significant figure. Now, how to write it to correct 2 significant figures? 28.76. Give your answer. Correct to 2 significant figures. So I need to have 2 digits which are different from 0, and the rest of them should be 0 here. So I should retain 28, and then the rest of them, these 0.76 should be converted to zeros. So now what do I see? Immediately after the line is 7, 7 is greater than 5. So 1 has to be added to the previous digit. So this is 29.00. This is correct to 2 significant figures. Now if I have 168.73 or 29, correct to 3 significant figures. So retain the 168, the ones with the highest value 168. Then you have the line over here, and after that is 2. 2 is less than 5, so ignore, change the rest of them to zeros. So the answer is 168. Had it been 16829 instead of the decimal point, your answer would have been 16,800. The last 2 digits are changed to zeros. So 16,800, correct to 3 significant figures. So always retain the digits with the higher value. Now, can you do this? 48,599, correct to 1 significant figure. I want correct to 1 significant figure. So just retain 1 digit. 8 is greater than 5, so add 1 to that, so it becomes 50,000. There is only 1 significant, the rest are all zeros. Now what about 0.08562, correct to 1 significant figure? Now this is a decimal. Here the first significant, the one with value occurs at 8. So retain that and see what comes after that. It's 5. So I need to add 1 before, so to the previous number, so it will be 0.09. That is correct to 1 significant figure. Because 5 or more than 5, you add 1. What about 0.00973, correct to 1 significant figure? Now here, after 9 you have 7. 7 is greater than 5. So add 1 to the previous one. So it will be 0.010. 9 plus 1, 10. So your answer is 0.01, 1 significant figure. Right? Generally, your solutions will be you will be expected to give your answer to 3 significant figures, and if it is a decimal, you will be asked to round it to 2 decimal points. So be careful when you are rounding it up. Just look at the number that comes immediately after that imaginary line that you draw. 5 or more than 5, add 1. Less than 5, just ignore, convert it into 0. Now, we have something called, you always need to estimate your answer, estimation. Estimation is a very important tool to have an idea of what is going to be your solution. You need not know the exact solution. Before calculation, you will not know what the exact solution is. But at least you will be able to estimate the size of your answer. How do you do that? You round your answers to the closest tens or hundreds or whatever according to the question. Perform the operation if it is multiplication or addition or division, which will become easier because you are having multiples of 10 or hundreds and then that will give you one, you can estimate the size of your answer. You can guess what the answer will be, in what range the answer could be. So this estimation is a very important tool to check your answers also, and also to have an idea of what your answer could be. So estimation plays a very important role in your calculations. So you can round your numbers to a convenient degree of accuracy. That is left to you. Nobody is going to say round it to the nearest 10 and then do the estimation. No. You can decide and you can round it to the nearest tens or nearest 100, and then you can estimate your answer. So we'll do a few examples in this. So if you want to calculate, estimate this answer. 6,388 divided by 31. Now I can see that 6,388, I want to round it to the nearest 1000. So this is approximately 6,000. Because 3 is less than 5, I choose to change the rest of the numbers to 0. And this is divided by 30. So 6,000 divided by 30 is 200. So my answer is somewhere close to 2000. May not be 2000, definitely not 2000, but it will be close to 2000. And let me do this on the calculator and see what it is. The answer is 206.00. So close enough. So this helps you. Okay. So if you are you do this calculation and then you get that 2068 or something, then you can be sure, oh no, my estimate is only 200 and here I am getting 2068. So this is definitely not my answer. Let me redo it. So that helps you to check your answer, and if it is not correct, you can always correct it with under the guidance of your estimation. So we'll do some estimations here and also check what the correct answer is. If I want to find cube root of 120 times 86. Now 120 is not a cube number, so it's going to be some decimal. It's an irrational number and I don't know what that is. But I can always choose a cube number close to 120. So the cube number close to 120 is 125. It's not far off, it's just 5 numbers more. So cube root of 125, and 86 is close to 90. Now what is cube root of 125? 5. And 5 times 90 gives me the estimate 450. This is my estimate of the answer. Now if I do this on the calculator, how do I enter this cube root of 120? You type in 120 in parentheses, then you write this raised to the symbol, and then you do 1/3, 1 divided by 3, and then multiply 30. This is how you will enter in your calculator. And this gives me, what does that give me? Let me try. I think it is 120 raised to 1 divided by 3 times 90 times 86, isn't it? It's not 90. Times 86. That's 424.2. So the answer is 424.2 and our estimate was 420. Pretty close. Now let us try these. (3,946) divided by 18. So my estimate is going to be 4,000 because 3,946 is close to 4,000. Divided by 20, the answer is 200, isn't it? Always you can check with your calculator what you get. And what about 5,620 divided by 12? That would be 6,000 divided by 10. Or that can be 600 again. Now what about 0.8 times 0.95? 0.8, the closest whole number is 1, and so also for 0.95 the closest whole number is 1. So 1 times 1 is 1. Now 9, sometimes it is enough if you round up one of those numbers. Round one number, the other one you can leave as it is, as in this example. 9.6 into 4 squared. So 4 squared is 16 and 9.6 is 10, and this is easy to multiply. 160 is your estimate. and your estimate may be different from your friends, but that doesn't matter. The answers what you get and what your friend gets, they will both be close to the exact answer when you try it out on your calculator, when you do it on your calculator. We'll see how we can estimate this area. Now we will estimate the area that is shaded. Yeah, this is given as 39.2 centimeters. This is given as 18.8 centimeters. This is 4.8. It's not drawn to scale, so, and this is 12. Now the shaded part is this. Now let's calculate the area. Now you know that the shaded area is area of the larger triangle minus area of the smaller triangle. Now estimate of the larger triangle, rectangle. So the shaded area is area of the larger rectangle minus area of the smaller rectangle. Estimate of the larger rectangle, the area. That will be 39.2. I'm going to round it to 40 because it's close to 40. And 18.8 is close to 20. So that becomes 800 centimeters squared. Now our estimate of the smaller rectangle. Okay, the other one can be 5, the width can be 5 and this I can retain as 12. So it is 60 centimeters squared. So shaded area is approximately 800 minus 60. The answer is 740 centimeters squared. So that will be approximately the shaded area. You can always calculate the exact ones using your calculator and you can compare with your estimate. We'll do another area question. So you have a shape like this and this length is 19.6 centimeters, 6.8 centimeters, 3.2 cm and this is 4.7 cm. And I want you to estimate this area. Not the exact area, I just want the estimate. So I can divide this shape into two rectangles. Get the area of rectangle A, get the area of rectangle B. Estimation. Get the estimate of A and the estimate of B. So area A can be estimated as 3 times 5, 15 centimeters squared. And area B can be estimated as, what would be the length? 19.6 minus 4. Maybe we can take it as 4.6. And that would be around 15 centimeters and the width is roughly 7. So it's going to be 105 centimeters squared. The 6.8 has been rounded to 7, closest whole number. And the length of that would be, it was, I had estimated that to be, this is 14.9. So that I took it as 15. I have taken that as 15. See, this 14.9 has been rounded to the nearest whole number 15. So that was 105. So the estimate of the area is 105 plus 15, 120 centimeters squared. You can do the actual calculation with your calculator, or you can take your time and multiply. Now one more word problem. A person earns $98,750 per year. Give an estimate. See, they're not asking for the exact value. Give an estimate of his weekly earnings. Now, how many weeks are there in a year? In 1 year, you have 52 weeks. So to get the weekly earnings, I divide 98,750 by 52. That gives me the weekly earnings. So I'm going to round it, both of them. So this can be rounded to 100,000. 98,750 is rounded to 100,000, and 52 is rounded down to 50, closest whole number. So if I do that, the answer is $2,000 per week. So you are getting a rough estimate of that. Now let me check on the calculator how close or how far away I am. 98750 divided by 52. That gives me the actual answer is 18,990. 1,899. So we have a figure which is slightly above 1,899 by roughly $100. Yes. So remember, before you do the actual calculation, you can get an estimate how, by rounding the numbers to the nearest whole number, or nearest 10, or nearest 1,000. However, you will know, when you look at the numbers, you will know. And then you round them up, and then, so that, why do we do this? It's easier to multiply and divide or do the calculation. So that's why we round it up to the nearest tens or hundreds, or to the nearest whole number. We can estimate the answer that way before we actually do the calculations.